So far we have discussed about the backups and recovery, where we have seen what are the types of backups that are available in Postgres and what is the difference between logical and physical backups, and what are all the utilities that are available, like to take the backups and to perform the restore procedures. So we have seen about pgdump, pgrestore, pgdumpall, and we have also seen a physical backup methodology called pg underscore base backup. So in today's class, we are going to discuss about one of the most important topic in Postgres database, which is a replication in Postgres. So we are going to discuss about what? We are going to discuss about the replication in Postgres. Where so we are going to see what is replication, what are the different types of replication that we have, and what are the steps that are involved to configure a streaming replication in Postgres. So this is very important. You can expect 2 to 3 questions from this topic altogether. Okay. Sometimes if you are keeping like 3 plus or 4 plus years of experience, the first question that would comes from the replication concepts only. So you have to be very careful and try to understand what I'm trying to explain. So unlike any other database technology like SQL Server or Oracle, replication is a high availability solution or disaster recovery solution, so which helps us to minimize the downtime and minimize the data loss in case of in case of database crash or instance crash or some abnormality that happen due to any issues. Okay, so the replication talks about like what can be done to recover the data, or what can be done to minimize the downtime in case of database crash or data center crash. So how the replication works? So we will be having, so this replication is common across all the RDBMS. It can be like a SQL Server, or it can be Oracle, DB2 or anything. So this high availability feature is there. So how it works in Postgres, right? So we will be having a master node, and we are going to create one more node called slave, and whatever the operations that are happened in the master, that will be, so whenever you perform any operation, what happens, actually an operation is going to happen in the shared buffer, and the metadata about the operation is going to get stored in the form of val file. So whatever the operation that happened, so what, and because of that operation, the val files are going to get generated, and those val files will be copied over the network to the slave side. Okay, those val files will be copied over the network to the slave side, and those val files will be applied on the slave to get the slave in sync with the master. So whatever the operations that are happened, those will be updated on the slave side. So whatever the data that is there in the master, the same data, the replica of the data or copy of the data will be available on the slave side. If something goes wrong with the master, what we can do, we can make this slave as a master to minimize the downtime and to avoid the data loss. So this is the purpose of replication. So how many types of replication that we have? We have a two types of replication. One is a streaming replication. One is a streaming replication, and second one is a logical replication. One is a streaming replication and second one is a logical replication. So what exactly mean by streaming replication? Streaming replication means we are going to replicate the entire cluster. Okay, so we are going to replicate the entire cluster. So whatever the operations that are happening in the cluster, those can be copied over the network to the slave side to get the slave in sync with the master. So whatever the logical replication, in logical replication we are going to replicate the logical objects. So we are going to replicate the logical objects. Okay, what are the logical objects that we have? So we are going to replicate the logical objects. What are all the logical objects that we have? So we have tables, so we can replicate couple of tables, or we can replicate the couple of databases, or we can replicate the couple of schemas in the using the logical replication. So in physical replication we don't have such option to replicate something else. Okay, so we can replicate entire physical structures of a Postgres cluster, whereas in case of logical replication we can replicate a particular table, or we can replicate a particular database among all the databases that are available in the Postgres cluster, or we can replicate, a particular schema from the list of schemas that are available in the particular database. That is the benefit of logical replication. Do we really use this logical replication in real time? No, we do follow a streaming replication, where we are going to replicate the entire Postgres cluster from one server to the another server. Okay, so what are the types of streaming replication that we have? There are two types of streaming replication. So there are two types of streaming replication. One is a synchronous streaming replication, and second one is a asynchronous streaming replication. So one is a synchronous streaming replication, and second one is a asynchronous streaming replication. The default one is an asynchronous streaming replication. So what is the default one? The default one is an asynchronous streaming replication. What exactly mean by asynchronous streaming replication is, so whenever something happened on the primary, the val file will be copied over the network, and once that is copied to the slave side, it will be applied on the slave, and that's how the slave will be in sync with the master. That is a normal process. In the asynchronous streaming replication, the master is not going to wait for the acknowledgement from the slave. Let's say you have sent some val file, and the primary or master is not going to wait for the acknowledgement. So let's say what happens, right? If something goes wrong between the primary and the slave side, or master or the slave side, and if the network is not available for 1 hour, so though the standby or slave server is not available, the master is not going to hold, or master is not going to wait for the acknowledgement. Master is going to continue with its operations. Okay, so this is about asynchronous replication. So what is a synchronous streaming replication? In the synchronous streaming replication, the master always waits for the acknowledgement from the slave. What does it mean? Right, so whenever val file is sent or copied over the network to the slave side, the primary or the master always waits for the response from the slave side. Let's say due to some network reasons, if the slave is not available, then it is not going to get the acknowledgement. When the master is not going to get the acknowledgement from the slave, then the master will be in indefinite wait state, and and it will be 1 minute. Hello, యా చెప్పండి. నేను ఒకసారి క్లాస్లో ఉన్నాను, మళ్ళీ ఏమంటారా ఒక హాఫ్ అన్ అవర్లో. So the master will be in indefinite waiting state, and it will be in hunger state. As the master is not going to get the acknowledgement from the slave, the master will be in indefinite waiting state, or it will not allow any transactions on the master side. So this is about the differences between synchronous replication and the asynchronous replication. Now let's try to find out the advantages of synchronous and asynchronous replications. What are the advantages of synchronous and asynchronous replication is, first of all, let's talk about the asynchronous replication. In the asynchronous replication, what is happening? So master is not going to wait for the acknowledgement from the slave, right? So here I have a master, here I have a slave. So these are through val files, it is going to get in sync. So here is the master waiting for the acknowledgement from the slave? No. Let's say, so there is a network issue between the master and slave for 1 hour. There is a network lag between master and slave for 1 hour. So during this time, if the master is crashed, what happens? If the master is crashed, then we need to make slave as a master, then how much amount of data we are going to lose? We are going to lose 1 hour of data we are going to lose. So that is one of the disadvantage with the asynchronous replication. So what is the advantage? So though the slave is not available, the master is not going to continue its operation. So independent of the state of the slave, the master will always be available. So availability is more. So what about the synchronous replication? So in the synchronous replication, master is going to wait for the acknowledgement from the slave. So at any point of time, there will be no data loss or minimal data loss, because the moment slave is not available, master is not going to allow you to perform any transactions. So whatever the data that is there in the master, that will also be there in the slave. So we can consider a zero data loss or minimal data loss in case of a synchronous replication. Whereas the disadvantage is, something goes wrong with the slave. If there is an issue with the slave, the master will be not available. If the master is not going to allow you to perform anything, then you would be seeing some downtime. So it affects the availability of the master server as well. So these are the advantages and disadvantages of synchronous and asynchronous replication. So the next point that we are going to discuss is, what are all the processes that are involved? Okay, what are all the processes that are involved in the streaming replication? There are 3 processes that are involved in the streaming replication. One is a val sender. One is what? One is a val sender process. Second one is a val receiver process. And third one is a startup process. Okay. So first one is a val sender process, second one is a val receiver process, and third one is a startup process. Val sender process sits on the master side, val receiver and startup process sits on the slave side. Okay, on the master side we will be having a val sender process, on the slave side we will be having a val receiver process and startup process. So what exactly the purpose of val sender is? Val sender is going to send the val files to the slave side. Okay, val sender process is responsible for sending the val files to the slave side, whereas val receiver on the slave side is going to accept the val files and it is going to store these val files in the pg_val location, and startup process is responsible for applying the val files which got received. Okay, so val sender process is going to send the val files, val receiver process is going to receive the val files, and startup process is going to apply the val files on the standby side or slave side to get the slave in sync with the master. So this is briefly about the streaming replication in Postgres. Now we are going to see, like there is a document which I have prepared for the streaming replication. Now let's going to go through that. So what is the replication? Replication is the process of copying data from one PostgreSQL server to the another PostgreSQL server, and the source database server is called as a master, and the server which is receiving the change is called as a slave. In Postgres, as we discussed, there are 2 types of replication. One is a streaming replication and second one is a logical replication. So what is streaming replication? Streaming replication is a standard feature of PostgreSQL, allows to update the information on the primary server to be transferred to the standby server in real time, so that the database of the primary server and the standby server will be in sync. Okay, so where do we use this streaming replication? So we can use this streaming replication in 2 things. One is a failover and second one is a read-only load balancing. What exactly mean by failover? So failover means, if you see this diagram, right? So there is a primary, okay, there is a primary and this is a standby. So there is a primary server and there is a standby server. If something goes wrong with your primary, see, if you see here, there is a failure that happened with the primary, then what we are doing? We are making the existing slave as a primary. That's how we are going to perform a failover. So how we are going to perform the failover? If the master is not available, if the master is failed due to some reasons, existing slave becomes the master. So that's how you can make the disaster recovery. And the second one is read-only load balancing. What does it mean by read-only load balancing is, so I have a master server and I have a slave. In Postgres, we have an option to open the slave server in read-only mode. So how we are going to perform the read-only load balancing is, so if we have any read-only queries, then we can redirect this read-only queries to the slave side. Instead of putting the pressure on the primary, we can redirect the read-only queries into the slave side, so that we are going to put some less load on the primary, and we are going to offload the load on the primary with the help of a read-only load balancing. So streaming replication mechanism, how the streaming replication works, we are going to see now. Streaming replication in Postgres works on log shipping. What exactly mean by log? Log is nothing but a val file. So PostgreSQL, so whenever a change is happened, it is going to get metadata about the change is going to stored in the val file, and in the streaming replication the val file will be copied. The val file will be copied or shipped to the standby side, and it will be applied on the standby server, so that the standby will be in sync with the master. Now we are going to see this diagram explains about how a val file is going to get generated and it will be copied over the network. See, this is a primary server and someone has performed an update operation. So whenever you perform an update operation, the actual update is going to happen in the shared buffer and metadata. This is what we call it as a metadata. The metadata about that update operation is going to get stored in the form of a val file, and this val file will be copied over the network to the slave side, and it will be applied on the slave side to get the slave in sync with the master. So whatever the operations that are happened in the master, those same operations are going to happen in the slave side as well, so that the master and slave always will be in sync. So now this is also an important thing. So how the val files will be copied and applied onto the slave side. So in this section, so we are going to discuss about what are all the different processes that are available in the streaming replication configuration to ship the val files and to apply the val files. In this diagram, I have one master server and I have two slave servers or standby servers. How many slaves that we can create? We can create any number of slaves. Okay, so I have a master server here and I have a two slave servers. Okay, in the master there is a process called val sender, which is going to send the val files to the slave side, and on the slave side val receiver is going to receive the val files, and startup process is going to apply those val files to get the slave in sync with the master. So what are the process? Val sender, val receiver, and startup process. So val sender is a process in master server which is responsible for sending the val files. Val receiver is a process which is going to receive, and startup process is going to apply. If you see the primary, whenever there is an update operation, val file is going to get generated. When the val file is going to get generated, val sender is going to send the val file, val receiver is going to receive the val files, and startup process is going to apply the val files. This is how the master and slave will always be in sync with the okay. What are the different types of replication that we have? We have a synchronous replication and we have an asynchronous replication. So let's find out the differences between the synchronous replication and asynchronous replication. In the synchronous replication, the primary server always waits for a response from the standby server. Therefore, in the asynchronous replication, the primary server completes the process without waiting for the response from the slave. So in the synchronous replication, the advantage is there is no delay in the val shipping, so there will be no data loss. In the asynchronous replication, as the master is not going to not going to know about the state of the slave, there might be a chance of data loss. So in the synchronous replication is suitable for the read-only load balancing, whereas asynchronous replication is suitable for the disaster recovery. Okay, this is how these are the differences between master and slave. So now we are going to see what are all the parameters that we need to set. Okay, what are all the parameters that we need to set to configure the streaming replication between two servers in a Postgres. Okay, the first thing that we are going to see, right? So I have my master server which is running on 192 dot 1 minute. What happened to this? Oh, Yeah. So I have my master server which is running on 192.168.29.125, and I'm going to create some slave right here. Slave would be on 192.168.29.132. So here what we will do, right, we will install only Postgres binaries. Install only Postgres binaries. Okay, now what we will do, so we need to set couple of parameters here, and once the Postgres binaries are installed, we need to perform a initial sync up. How we are going to perform the initial sync up? We are going to perform the initial sync up through pg base backup. We are going to take the pg base backup for of this primary server to get the initial sync up. So as we discussed, pg base backup is going to work on which protocol? pg base backup is going to work on a replication protocol. So whatever the user that you are trying to use to connect to your master, so an entry will be added in the pg underscore hba.conf file to allow the replication connection. That is what I have written here. Okay, if you see, set the create the user in the master using a whichever slave should connect for a streaming of the val files, then that user should be have a replication role, and an entry will be added in the pg underscore hb.conf file of the master to allow the replication connection from the slave. So the first step I need to do, right, through whichever the user you wanted to configure the streaming replication, that an entry will be added in the pg underscore hb.conf file of the master to allow the replication connection. Now the next thing that we are going to discuss is what are all the parameters that we need to set to allow the streaming replication. So the first parameter that we are going to set is listen underscore addresses should be star. So by default anyway it is star, because when if the listen underscore address is star, then only it is going to accept the remote connections. The val level should be replica. What exactly this val level talks about? This val level talks about how much amount of val that needs to be generated. So why, so but the default value itself is a replica. So when you set val level to replica, it is going to generate a val file that is that supports the streaming replication. Okay, if you want to support a logical replication, then val level replica should not help us. We need to make val level equal to logical. Then it is going to generate a more logging so that the logical replication will be supported. Max val senders, if you remember, when we were talking about the process that are involved in streaming replication configuration, there is a process called val sender. So val sender is a process which is responsible for sending the val files from master to the slave side. So there is a parameter associated with max underscore val underscore sender. The default value of this max val senders parameter is 10, and so it is always recommended to have number of standbys plus 1. Suppose let's say if you are going to keep 11 or 12 standbys, the max val senders parameter should be 13. Okay, if you are going to keep 2 standbys, then the max val senders parameter should be 3, minimum 3. So but the default value is what? 10. So do we need to change anything? No. So max connections talks about number of connections that the Postgres cluster is going to accept anyway. It should be the value that is greater than max val senders. The val keep segments is a parameter which talks about how many val files that needs to be retained in the pg underscore val location. And val sender timeout talks about after how much amount of time master should think that the slave is not available. So if the slave is not available, then the master is going to wait for the val sender timeout time to after this time the master thinks that the slave is not available. Synchronous standby names, this will comes into picture when we are going to enable the synchronous replication, so that we will be discussing during the synchronous replication configuration. And synchronous commit also we are going to discuss during the synchronous replication configuration. Archive mode should be on, archive command should be enabled. So do we need to change any parameters? No, because by default max vals under system val keep segments is more than required and max connections is unlimited, so no need to change anything. If the archive log mode is not enabled, then you need to enable it, and if the archive command is not configured, then you need to configure it. So already we have seen like how we can enable the archive log mode and how we can like set the archive command to archive the val files, that already we have seen. And settings on the standby server, the only thing that you need to do is you need to install only Postgres binaries. Once the Postgres binaries are installed, then we need to call pg base backup to perform a initial, what we need to do to perform the initial sync up. So once that is done, the val files will be copied to the slave side and it will be in sync with the master. So while calling the pg base backup option, we need to add an extra attribute. So far what are we using? We are using pg base backup -u -h -x -f and -p, right? Now you need to use an option called -R. So what exactly this -R will do? When you pass or when you use pg base backup with -R option, then it is going to set couple of parameters which supports the streaming replication, like primary connection info. It is going to set one parameter called primary connection info, which contains the user details and the host details that are required to connect to the master server to get the val files from the master. So these are the param. And so if the Postgres version is less than or equal to 11, okay, less than or equal to 11, we are having some file called recovery.conf. So this recovery.conf is a configuration file where we are going to keep this primary connection info and all those things. From the 12 onwards, recovery.conf is replaced with a whatever the parameters that are there in the recovery.conf, we can keep those parameters in the standard parameter file called postgresql.conf only. So in the standard parameter file called postgresql.conf, and the recovery.conf is replaced with a empty file called standby.signal. How can you identify whether particular server is a master server or slave server, right? So go to the data directory. In the data directory, if you see any file called standby.signal, which means that is a slave server. So once pg base backup initial sync up is done, so through the primary connection information, the slave is going to fetch the val files from the master to get the in sync with the master. So this is briefly about the like the theoretical part of the streaming replication. In the next class, so we are going to see how can we configure the streaming replication and how can we recover the standby or slave server in case of any like any lag between master and slave, and what are all the options that are available. And also we are going to see the standard synchronous replication. How can we configure the synchronous replication, and how can you how can you differentiate between a synchronous and asynchronous replication? How can we do a switch over, and how can we do a failover? All those things we are going to discuss in detail in the next two classes. Okay, so that's it for today. So any doubts so far? Any doubts so far? So guys, see, if you guys are, as I have told you many a times, so what are the discussion that has happened 7 to 8 days back? That is nothing. Okay, user management, database management, schema management, table space management, parameter, that is nothing to do with that. So if you are going to keep like 4 plus or 5 plus or 3 plus at least, or 3.5 or something, then you have to have a thorough understanding of the backups, recovery and replication. I hope you guys are practicing it. So just I want you guys to practice and just call me if you guys are stuck anywhere. Okay, I'm always happy to help. So not only now, so once this entire session is done, then also I'll be happy to help you. So whenever you get some doubts, or if you did not attend some classes or something, feel free to. So there is another batch which is going on currently. They are in the database, I think, schema management. If you want to join, just let me know so that I can forward you that invite as well. Okay, but the only thing is, there are a lot of openings outside. I want you guys to practice, and let me know if you have any doubts. Okay, and that's it for today, and we'll connect tomorrow. Okay, so guys, I think if needed, we have to have a class